Our sun feels familiar. It rises every morning, sets every evening, warms our days, and lights our lives. We think of it as ordinary, just another star in a galaxy of hundreds of billions. But look more closely, and a mystery emerges. The sun is alone. And that may be strange, because most stars in the Milky Way are not solitary wanderers. They are born in pairs, or in trios, or in swarms, companions for life. Which leads to a haunting question. If most stars are twins, where is the sun's missing sibling? Did it once exist? And if so, where did it go? The idea that the sun once had a twin is not new. For decades, astronomers have debated a hypothesis known as Nemesis, a proposed companion star that might have circled our sun in deep, elongated orbits. Its name comes from mythology, a goddess of retribution. Nemesis, the star, was imagined not as a bringer of warmth, but of catastrophe. Its gravity, sweeping through the distant Oort cloud of icy bodies, could have nudged comets inward, sending swarms of them toward the inner solar system. Some scientists even wondered if periodic mass extinctions on Earth, such as the one that killed the dinosaurs, might have been triggered by Nemesis's cosmic influence. It was a chilling idea that Earth's greatest biological catastrophes might be linked to a hidden twin star, orbiting unseen in the dark. Astronomers searched the skies for Nemesis, looking for faint red dwarfs, brown dwarfs, or other companions, but found nothing. Infrared surveys ruled out any nearby star that could be bound to the sun today. If Nemesis ever existed, it is gone, and yet the mystery deepens, because Nemesis may not have been just a wild guess. Statistically, the sun should have been born with a companion. Observations of star-forming regions show that most stars are born in pairs. Binary stars are the rule, not the exception. Even systems with single stars often appear to have lost their companions in the chaos of stellar nurseries. That makes the sun suspicious. Why should it be one of the rare loners? Did it always travel alone, or did it once have a sibling torn away? If the sun's twin existed, what was it like? Perhaps it was a faint red dwarf, the most common kind of star, too dim to notice without careful searching. Perhaps it was similar to the sun itself, almost a mirror image, a sibling that could have shaped our system in ways we still don't fully grasp. Perhaps it strayed too close to other stars in the crowded cluster where the sun was born, and gravity ripped it away, casting it into the galaxy. Today, that sibling could be tens of thousands of light-years distant, just another anonymous star among the billions. But the Nemesis idea lingers because of the tantalizing patterns it tried to explain. Some paleontologists claim mass extinctions on Earth happen in cycles, every 26 to 30 million years. Such cycles could, in principle, be caused by a companion star disturbing cometary orbits in regular intervals. The evidence is debated, the cycles not universally accepted, but the coincidence is provocative. If Nemesis once existed, it may have played a hidden role in the story of life on Earth, sometimes as a destroyer, sometimes as a catalyst, shaping evolution by catastrophe. Even without mass extinction links, the missing twin raises profound questions. If most stars are binaries, then the sun's loneliness is a clue. It suggests that our solar system's early environment may have been violent, with stellar siblings jostling and scattering each other. It suggests that the architecture of our system, the wide spacing of the planets, the distant Oort cloud, even the tilt of orbits, might bear scars of an ancient partner's influence. Some astronomers even speculate that the elusive Planet 9, the hypothetical giant world far beyond Neptune, might be a remnant of those early gravitational games, its orbit sculpted by the sun's lost twin. So where is Nemesis now? The truth is, if it existed, it may be untraceable. Stars do not carry name tags linking them to their birth siblings. As clusters dissolve, stars scatter across the galaxy, losing all memory of who they once orbited with. Somewhere in the Milky Way, there may indeed be a star born from the same cloud as the Sun, a true sibling carrying the same isotopic DNA. We have found candidates, stars with similar chemistry, moving in similar directions, but none confirmed as the long-lost twin. The galaxy is simply too vast, too crowded, too full of chance encounters. And yet, the search continues. Large-scale stellar surveys, like those conducted by the Gaia spacecraft, are mapping the motions of billions of stars. Within that data may be hidden the Sun's family tree. Perhaps one day, we will pinpoint a star whose origin matches ours, a sibling drifting far from home. Perhaps we will discover that the Sun is not an orphan after all. There is another possibility, one more exotic. What if Nemesis was not a normal star, but something darker? Some theorists suggest that the Sun's companion might have been a black hole, a remnant of stellar death so faint it escaped detection. A small black hole, drifting at the edges of the solar system, could be invisible except through its gravitational pull. Could the Sun's twin still be out there, not lost to the galaxy, but hiding in its own shroud of darkness? Dark matter surveys and new sky scans may someday reveal such ghosts, if they exist. But whether Nemesis was a star, a black hole, or simply a myth, the deeper mystery remains. The Sun is alone in a universe where loneliness is rare. Its missing twin forces us to confront how little we know about the birth of solar systems. If we cannot explain why our own Sun stands solitary, how can we hope to explain the diversity of exoplanets, the chaos of other systems, the conditions for life itself? And so the Moon pulls our tides, Earth circles its solitary star, and humanity asks the question, what if it was not always alone? What if the Sun we trust each morning was once part of a duet, a cosmic pair that danced together at the dawn of time? What if its missing twin shaped not only the solar system, but the very path of life on Earth? The answer is hidden in the stars, in chemical signatures, in faint gravitational traces we have yet to decode. The search for Nemesis is not just about one star, it is about our origins. If the Sun's twin is found, it will rewrite our story. If it never is, the mystery itself will remain a reminder that even the ordinary Sun, the most familiar star of all, is not ordinary at all. So the next time you see the sunrise, remember, our star may not be what it seems. It looks alone. But perhaps, long ago, it was not. Perhaps it had a twin, a secret companion that vanished into the galaxy, leaving us with questions instead of answers. The Sun's missing twin is not just a curiosity. It is a riddle about who we are, where we came from, and whether the story of life is written by companions we can no longer see.